Okay, so for this one, the free body diagram, there's the weight force, 147.15. There's the normal force. There's a 200 Newton force there. This time, the block's sliding down the incline, so the friction force is this way. So Newton's second law says, what were those values again? The negative 94, negative 112. So there's the weight. The normal force is always the same, 0n. The friction force is always plus or minus in the x direction and then 0 in the y direction. In this case, that's positive x. (200, 0). And what's the acceleration? A0. So n is equal to 112. What is 112 point what? 72. And so now plug that into the x equation, and it's 94 point what? Plus 0.2 times 112.72 plus 200 is equal to 15a. And so what do you get when you add all these numbers together? 127.1995, okay, is equal to 15a. So what's a equal to? What, 8? 8.5? So the acceleration vector is equal to 8.5 meters per second squared, 0. Okay, so the acceleration here, so this is sort of an interesting thing that happens due to the friction force. Remember, when there was no friction, no matter what the velocity was at that instant, we had an acceleration up the ramp of 7, right? When it was sliding down the ramp, when it was sliding up the ramp, so friction was down the ramp, the friction force was still positive, but it was smaller than when there was no friction, okay? That's because the friction force was acting in the opposite direction of that big 200 Newton force, okay? Then when it was sliding down the ramp and the friction force was up the ramp, we got an acceleration that was bigger, more positive than that acceleration when there was no friction. And that's because by changing the direction of the motion, we changed the direction of that friction force, okay? Anybody have any questions about how this all works? Okay, let's do another one.
Would you say this is about the difficulty level of the ones on the test?
Those two are about the difficulty level of the ones on the test. This one is going to be harder. But I think there is a practice problem that's sort of like this. But okay, say that you have a 10 kilogram box on top of a 15 kilogram box. They're sliding along the floor. And they're connected by a cable that's going over a pulley. And let's say that you pull with 100 newtons on the top box this way. Okay? So between the boxes, let's say that the coefficient of friction is 0.1. Between the floor and the 15 kilogram box, let's say the coefficient of friction is 0.2. And let's say that the top box has a velocity that's going to the left. Okay, so the top box is moving to the left. One thing that you're going to need to do this is you're going to need to recognize the relationship between motions, and this is sort of like what we did and what we're doing in lab this week. Any motion of the top box totally determines the motion of the bottom box and vice versa, right? Because this cable, you know, there's a relationship between those. And so if the top box accelerates with a certain value to the left, the bottom box has to accelerate with that same value to the right because they're fixed relative to each other. Okay? So the way to represent that is you can think of the acceleration of the top box as A0 and the acceleration of the bottom box. So what do you think that would be? If the acceleration of the top box is A0, how are we going to represent the acceleration vector of the bottom box? Negative A0, yep. So whatever A is, 5 meters per second squared, one's going 5 meters per second squared to the left, and the other one's going to the right. Okay, so see if you can, so I guess let's first just get the free body diagrams. After you do that, I'll do it, and then after that you can go back and calculate the acceleration. So first just draw the free body diagrams of those two boxes.